Today's session is about collecting primary data and different tools that are available to collect data and then publish the data on the GBIF. Yesterday, there was a session on the Blue Zone that was sponsored by the European, the EBRD, European Bank for Development. And they talked about the importance of sharing primary data that is collected as projects are evaluated or scoped out. Okay, so c'est toi qui m'en informe, huh? No, see, Carrie, you were the first one to go. Okay, so our first speaker is Carrie Seltzer from iNaturalist. Carrie is with us in the room, so I'll try to switch the camera over so you can see and hear.
Thanks, everyone. So I'm pleased to share some about what we're doing with iNaturalist, how iNaturalist crowdsources data from all over the world about biodiversity. Next slide. We know we're here in Cali, Colombia, because of the incredible challenge of climate change and habitat destruction that is threatening over 1 million species with extinction. Next. And in order to really take action, we need both really engaged people who care about biodiversity, and we need the information based on data to guide effective conservation. Next. So iNaturalist is building a global movement for biodiversity to meet these challenges that involve both people and data. Next. The way we do this is by building scalable technology that allows millions of people to share their observations of biodiversity, and supported by over 100,000 expert naturalists who are adding identifications. Collectively, we crowdsource the world's most diverse and dynamic biodiversity data set. Next. Our platform includes both web, mobile apps. We have a privacy-conscious, kid-safe app called Seek that isn't focused on data collection, but is focused on engaging people in exploring biodiversity around them. And open data is an important part of our mission. We have an API, and we also regularly share data with GBIF. Next. So I want to show just one example of how this crowdsourcing process works. So this is an observation that was posted in a place from a sanctuary near my home in Washington, D.C. And you've got the location, you see who posted it, you see when they posted it, and then you can think of every observation as an invitation to a conversation about what it is that you saw. Next. So people start chiming in with comments about identifications. Next, and there's a conversation, and eventually they come to this community consensus that the species documented was an oak stag beetle. Here's just one small example, and there are now over 200 million of these. Next. So just like we crowdsource species identifications on iNaturalist, we also have a data quality assessment section, which is where you can flag records if they have incorrect locations or the date looks wrong. So we really rely on the community for all of this. And you can see that this observation is also shared with the Global Biodiversity Information Facility, or GBIF for short, because it has an open license and it is a research grade observation, which means that it has agreement at the species level. Next. One of the ways that iNaturalist is able to do this is by having a single underlying taxonomy. There is one tree of life, and that makes iNaturalist a place for both generalists and specialists, because anything that you can attach to the tree of life, you can observe on iNaturalist. Next. And there's so much activity. This is a snapshot from just 1 hour, And in this hour, we expect about 5,000 new observations and about 12,000 identifications. And it is truly happening across the world. Those lines are connecting the location of an observation in orange to the location of the person who's identifying that observation. So you can see that there's a lot of exchange that happens within regions, but also across. Next. And like I mentioned, we've now got over 200 million observations globally. You can see some of our hotspots, and we still have many, many more areas to reach. Next. You can see how iNaturalist has grown over time. This year, we passed more than 6 million observations per month. And you can see that the seasonality of iNaturalist activity tends to follow the warm season in the Northern Hemisphere. Next. We share the shareable subset of research grade data with the Global Biodiversity Information Facility, and iNaturalist data has been cited in well over 5,000 publications now, which we're proud to share is the most of any publisher to GBIF. Next. Also, if you look at just the most recent data shared with GBIF, so the last decade, and this is the information that we especially need to know where things are right now and how we're going to be able to protect them as our climate changes. iNaturalist has nearly 400,000 species represented on GBIF, and that puts us in a class of our own. We've got the unique ability to census over 100,000 species annually. Next. When it comes to photos of biodiversity, iNaturalist is also far and away the biggest share of these images. On GBIF, we have over 300,000 species represented in images. And overall on iNaturalist, we have nearly 500,000 species now, and that's about 25% of all described species. And most of the images you can find on GBIF right now are from iNaturalist, especially in the last decade. Next. So if it wasn't clear already, I just want to emphasize that just like many hands make light work. Next. We think that many eyes make for good data. I know our model is to be very open and inclusive, and not only we hope attract experts, but hopefully cultivate new ones through involvement in the identification and observation process on iNaturalist. Next. So what we've been able to do with all of this crowdsourced data on iNaturalist is, well, we've checked it. We have evaluated that about 1% of our research grade observations are incorrectly labeled. We have a few other percent that we aren't able to assess, so essentially uncertain. And the precision of the research grade data, because that's part of our definition at species level, tends to be very high. When it comes to observations that are still in this category that we call needs ID, the percent that's correct is obviously a lot lower, and also tends to have much lower precision and also more uncertainty. Next. So one of the things we've been able to do with all of this data is develop our own computer vision models for detecting visual similarity of species. So this is an example of a photo that I took in my neighborhood in Washington, D.C. And when you get suggestions within the iNaturalist app or on the website, you can see that the model is pretty confident that it is a violet in the genus Viola. And then it also gives some species suggestions of some of the violet species that are most visually similar. Next. But we all know that geography is also really important for identification. And so we've also been able to, just like we've done with computer vision, we've been able to use machine learning on this same set of about 100,000 species that we have enough data for, we can also make predictions about where species may occur. Next. And combined with our computer vision results, this is especially helpful. So sometimes you have for example, two lizards that are very visually similar. And so using computer vision alone, it can be really difficult to tell them apart. But when you put in the geomodel as well, and you can see that only one species is likely to be found in the middle of Nebraska there, that way we're able to give more confident suggestions. Next. So each time we update our computer vision model and our geomodel, which is happening now once a month, we compare the two models, and we also look at how accurate the model is with computer vision alone, which is shown in the lower darker green bars, and how much additional accuracy is added by also including the geomodel, and that's the lighter bar on top. So you can see that overall our accuracy is close to 90%, but that it varies quite a bit taxonomically as well as geographically, with the highest precision ones being in actually plants, as well as Europe and North America. Next. And one of the cool things about iNaturalist, the iNaturalist community, is that we've really seen this excitement in the community because we're training these models about every month now. The community is really collaborating to get more species across this observation threshold so that it can be included in the model. And so there's a few comments from members of the community, highlighting that they can see their work reflected in the species that are added to the new model. We're adding about 1,000 to 3,000 species each month. Next. I just want to conclude by acknowledging that none of what we do would be possible without the incredible iNaturalist community. I know that some of you are joining us remotely, and some of you are in the room, and we're just so incredibly grateful for everything that you do. Thank you.
Thank you, Carrie. Wonderful. We'll take questions at the end. So if there's a Q&A feature in Teams, so you can send your questions through that, and we'll take that at the very end. Maybe you can. I'll just.
You want to trade places?
I'll move the camera. Okay. Excellent. Okay, so our next speaker is my dear colleague and friend Renal, who's Renal Brunois, who's a biodiversity expert at BIOTOPE, and he'll talk about one tool that we've been using, that we developed and we've been using internally to collect primary data.
Yes. Thank you, Eric. Hello, everybody. Hello, specific hello to people that are being online at this event. So I will present a specific presentation today about how does a company, a consultancy as BIOTOPE, ensure primary biodiversity data quality. This is a key issue. Collecting data is one thing. Having quality data and useful data for the purposes of its collection is very important. So my presentation will be in three main points. How does BIOTOPE collect primary biodiversity data first? The skills of the people, which is the first key to data quality. And finally, a short presentation of a tool, an app, that has been developed by BIOTOPE to guarantee data quality, an app called Shuriken. So first of all, how does BIOTOPE collect primary biodiversity data? Very quickly, at a glance, BIOTOPE is a French-based consultancy specialized in biodiversity and ecological engineering. So we have more or less 15, 17 offices around the world, mainly in France, and also a few affiliates from China, Madagascar, Gabon, South America, Colombia, etc. BIOTOPE services are divided into different categories. So risk and opportunity management for economic sectors. This is one of the main sectors where we gather data directly from the field. Also, sustainable management, conservation, and restoration of ecosystems. We also gather a lot of field data from these activities. Then we provide support to our client in the design of their policies, or also in the evolution of their practices, their corporate strategies, as an example. So enough about BIOTOPE. Let's talk about data now. This is a rapid presentation of the amount of data we have already gathered from 2015 to 2023, so close to 10 million of data, mainly represented by bat sound recordings, 70% of the general amount of data. A lot of data regarding birds and plants also. And a specific category, there are 3% of the insects within this amount of data. And a specific category that can be divided in other categories. 12% of the other categories are represented by mammal data. Also amphibians, reptiles, fish, and other taxa. These data come from mainly Europe, Africa, Asia, and South America, specifically French Guiana. Excuse me, I have to proceed. So, see my screen, yes. So the data collection within BIOTOPE is based, as I said before, on a specific tool that is called Shuriken. Shuriken is divided into three parts. First of all, the cloud, a secure data center, where all the species information, the species checklist, the taxonomic standards, we'll come back about this later, are gathered, stored. For office work on the data, we have a specific web app of our tool Shuriken. And to collect directly data from the field, we have another app, mobile one, available on digital tablets, which allows to collect directly data from the field. In addition to that, batch of data can be incorporated from other source of data. For example, a large amount of data from camera trap surveys, from sound recording surveys, and also eDNA surveys. So this is at a glance. And then once all the data has been gathered into the cloud, they can be exported in a any formatted format. We use generally two formats, the GBIF one to share the data, let's say, in a worldwide way. And also DPOBIO is a specific format in the French French regulatory framework, because all the data gathered in the framework of environmental impact assessment in the French territories, the regulations require to share the data on a specific platform called DPOBIO, Deposit of Biodiversity for the non-French speakers. One key issue in the data quality is, of course, the skills of the author of the data, meaning the skills of the field practitioners, the field naturalists that collect the data on the field. Just as a reminder, this table presents the level of knowledge in terms of the number of described species and also the number of species evaluated by the International Union for the Conservation of Nature through the Global Red List. We can see it can illustrate the level of knowledge we have regarding biodiversity and the level of knowledge we have because of the availability of data. As key examples, we can see that the birds are well known and all the bird species are evaluated through the IUCN Red List. This is the good example, let's say. If you look at the line insects, the third line starting from the end, about 1 million of species described, but only 12,000 of species evaluated. Regarding the plants, I'm a botanist, I have to speak about plants. About 369,000 species described, but only close to 70,000 species evaluated, last version of the Red List. So there are a large number of species, many are still unknown, and it can be very difficult to recognize the various species. This requires an ability to memorize the ecology and the identification criteria of a species, and a very important self-investment, especially in taxa that are complicated to recognize, such as insects, plants, somehow fish. So the skill of BIOTOPE employees, we have in-house high qualified staff to collect and manage biodiversity data. It can be divided in 3 main categories: professional naturalists, ecologists with knowledge of the species. We have botanists, we have mammalogists, we have bat specialists, fish specialists, etc. Expertise in methods and field protocols, including the appropriate sensors and related technologies. And of course, an extensive experience of the field work. We also have data scientists, including biostatisticians, as an example, ability to define. They have the ability to define an appropriate sampling protocol, and they use most effective to date analysis methods such as population viability analysis. And in addition to that, because our job requires often a mapping, a graphic representation of the results in the context of a project or a protected area, we have specific GIS experts who are able to manipulate, to transform, and to add value to the geolocalized data. In order to hire all these people, we have specific recruiting process based on a knowledge test, and also in close collaboration with academics and universities. Internally, we provide regular internal and external training in order to improve more and more the skills of the people within the company. So this is the first aspect of the data quality based on in-house experts with specific skills that are able to collect themselves the data on the field, but who are also able to support the collecting of data with partners, because we don't have worldwide knowledge of the biodiversity, of course, and we used to collaborate with local partners such as local consultancies, local NGOs, in order to collect data on the field, also local authorities. Sorry. So we follow a specific selection process to choose our partners in terms of field data collecting. So permanent networking to find, let's say, the best experts, identification of local correspondence with the support of our international partners, such as international NGOs, and systematic skills assessment of potential partners. So it's generally a win-win collaboration, mixing international staff, let's say coaching or giving a technical framework to our partners, technical assistance, and the local partners support us in terms of field knowledge, in terms of ecology of the species knowledge in specific landscape or seascapes, and kind of win-win collaboration. We're always very happy to share field collection surveys with our partners. So now I have discussed about the skills of the people who are collecting the data, but we can help those people with specific tools, and Shuriken is one of them. So Shuriken is an in-house tool developed by BIOTOPE. And what is very important is that Shuriken can gather both the protocols to collect the data and the data themselves. So as written on that slide, BIOTOPE collects much more valuable data through standard protocol and sampling events. Standardized protocols are very important because they allow for monitoring on the long term of, for example, habitat coverage, species populations, any threat in the landscape, everything you can collect through monitoring in the landscape based on standard and replicable protocols. Example of protocols we carry out in the field. So basically, exhaustive list of species, just a species list, not very interesting in an ecological way. Sound recording points for birds and bats, especially ultrasound recording for the bats. DNA sampling, phytosociological surveys. This is for the plants, the community of plants in the field. Camera trap surveys with specific protocol, etc. Distance protocol with camera trap, combining the photo and the distance to the trap. Very interesting to quantify the population in a specific landscape. This is an illustration that all data are, of course, geolocalized in order to support both mapping and statistical analysis about the use of the species of the landscape or seascape. So they can be, when the data are collected, they can be geolocated directly during the survey or at observation level. They can be collected as a point, a line, or a polygon. So you can say this is a patch of population of this species with the polygon. And at the observer's position using the tablet GPS or by plotting directly on the map the information. So geolocation of the data. Then how to name the species. To date, we use the GBIF backbone taxonomy and the catalog of life that are, in my understanding, being starting to merge as much as possible, because it's very important to name the same way and to update regularly the taxonomy of the species, because science progress, taxonomy science progress, and taxonomy is one of the key issues to name a species first, to assess a species in a specific landscape, and also to evaluate the issues or the threat level of a species. In France, I said before that we have a specific process to share the data from impact assessment. We use a specific mandatory referential, which is called taxonomic referential. In order to support the data collection and to avoid a maximum of mistakes or of errors on the field, Shuriken can provide specific lists in a specific regional or local area. So you can filter the different species in order to avoid misinformation in the data. Another way to check the quality of the data is when we deliver the quality control at the end of the study process. Specific control is done about the data quality, and we check the biogeographical position of the information. So you have a screenshot of the web app from the laptop tool Shuriken. The example is the wolf Canis lupus, with the various synonyms or subspecies available in the taxonomical reference. In addition to the species itself, also, as I said before, sugarcane allows to add additional information. This screenshot is a good example. It is a bird species observation. The first row shows, let me check with my laser. Yes, the first row shows the age of the individual that has been observed. This is an adult. The second row is a standardized level in terms of probability of breeding in the area surveyed. In that case, we are certain that the species is breeding. The other categories are non-breeding, possible breeder, likely breeder, probable breeder, and a certain breeder. We can check if it's a female or male, as an example. We can inform species has been seen or heard, or any other presence information to track, for example, or also if the species has been captured through a camera trap, through a real trap. For amphibians, for reptiles, we often use real traps. So you can add to the data a lot of field and protocol information. As a conclusion, our tool allows us to gather a lot of interesting data, high-value data, because they are closely related to the protocol with which they have been collected. This is key to develop more and more the sampling events in the GBIF platform. But we recognize that our data is still underexploited. We have a lot of information, but now we need to use that information in more ways, specifically statistical ways, in order to better inform the ecology of the species or the traits of the species within the specific landscape we are studying. This can inform, as an example, the impact assessment of the development project or the management measures in a specific protected area. Such data set may have a lot of potential application. One of them, based on our big amount of bat recording, both at the level of the ground and in altitude, based on a measure maps. We gather a lot of information about activity of the bats, and this allows us to provide risk maps for the installation of wind power plants, wind farms in the French territory. So these two maps provide the illustration of the level of activity of a specific bat species, both at ground level and in altitude. This can allow, for example, to curtail the curtailment of the wind farm, of the turbine, in order to avoid bad collisions with the blades. So that's just an example of application of what we can do with a lot of data to support both development and biodiversity conservation. Many thanks to all the people that have heard to me. Feel free to ask questions when it will be opened by my colleague. Many thanks again.
Thank you, Anand. Okay, so now for a big unknown, we'll try to play the video from our colleague Kyle from GBIF. So if you can bear with us, and if again some of you could please mention in the chat session if you can hear the video once I start playing it. Thank you so much.
Hi everyone, my name is Kyle Kopis and I'm Communications Manager at the GBIF Secretariat in Copenhagen. I'm sorry that I'm not there yet with you in Cali, but I will be soon. and I'd like to encourage you to track down my colleagues and I if you're a COP. A little bit more on that at the end of this brief talk. Today, I'd like to talk about some of GBIF's current activities serve to improve the quality of taxonomic, occurrence, or presence-only and monitoring data on biodiversity. To do that, I'd like to start by taking a look at something of a short history of GBIF. GBIF's roots really lie in the scientific collections community, using their unique value and common needs like taxonomic data to set things in motion for the infrastructure. But by the middle of the 2010s, the boom in data from citizen science, community science projects, including vast ones like eBird, iNaturalist, and observation.org, along with many smaller ones, prompted changes like support of near real-time enterprise-scale data processing. By 2020, the improved scalability of GBIF's infrastructure and the success of its network in working with DNA infrastructures prompted the extension of standards and development of materials to ensure the representation of molecular-derived data in the GBIF index. Now we find ourselves and feel we're prepared to meet the demand for improving the support of survey and monitoring data in order to advance the implementation of the Kunming-Montreal Global Biodiversity Framework. So let's look at the tools we have available for these tasks. GBIF provides access to 4 different classes of data sets. We have metadata-only data sets that describe resources that exist but whose individual records are not yet accessible online. Taxonomic checklists, which are lists of named organisms organized by taxonomy, geography, and other themes. Species occurrences that record the observation and collection of named organisms, often species, in time and space. And sampling events, which provide the means for quantitative monitoring according to standardized protocols. Even if you're familiar with GBIF, you might be surprised to know that a slight majority of the data sets shared through our infrastructure are taxonomic checklists. In the confines of this brief talk, I want to focus on efforts to improve each of the last 3 classes of data sets, but I do want to give credit where credit is due and note that more than 52,000 of those checklists are shared by our partner Plazi, a Swiss nonprofit that's dedicated to liberating taxonomic data from scientific literature. There's no time to get into specifics, but Plazi's success in closing gaps in nomenclatural data on GBIF should inspire us all. But let's stick with taxonomy for a moment. Many of you will recognize the Catalog of Life as a collaborative network and infrastructure of taxonomic experts around the world. And GBIF has literally built its world around COL from the start. They produce both annual and monthly updates to a global consensus-based list of scientific names that are essential to GBIF and others who need to organize biodiversity data. In recent years, GBIF and COL have become closer, having both been recognized as global core biodata resources. Infrastructure is essential to the wider biological and life sciences community, as well as to the long-term preservation of biological data. GBIF is also now the technical host of COL's infrastructure and the administrative host of its secretariat. Much as we love them, COL has never been able to serve all of GBIF's needs for scientific names. A few years ago, we added support for operational taxonomic units, or OTUs, which are used to identify potential species that have only been identified from DNA evidence. But even before that, COL's rigorous editorial processes haven't been able to keep pace with GBIF's rapidly growing index of biodiversity data. Out of necessity, GBIF has maintained its own taxonomic backbone, which adds names from a few hundred more taxonomic checklists to those in COL. This work has always been challenging for us, so several years ago we began working with the Catalog of Life to support both of our respective sets of needs. The result is Checklist Bank, a co-developed infrastructure and repository for taxonomic data that has streamlined production of the Catalog of Life and is now on the verge of producing an extended Catalog of Life release that can replace the GBIF backbone taxonomy. This work is now being tested, and we hope to have it in production by late 2024 or early 2025. Once that happens, we expect to engage the wider taxonomic community because Checklist Bank offers a workbench of tools useful to anyone working with taxonomic data. I'd like to switch over now to talking about an effort aimed at improving the quality of occurrence data sets available through GBIF. In 2022, GBIF began a multi-year research and development effort aimed at understanding and addressing known limitations in the Darwin Core Standard that powers much of the data in GBIF. While this community-led standard has been a cornerstone of GBIF's success to date, its so-called STAR schema flattens and reduces the amount of detail available in source data sets. We wanted to change that. Through an extensive exploration involving a broad constituency of more than 20 different data communities, some of which you can see here, we developed case studies aimed at understanding how to rethink the limiting factors in Darwin Core and overcome these shortcomings. The process also gave us the chance to engage communities that have either not used the standard or used it only grudgingly. This work has matured into a broader conceptual model that's capable of being supported by targeted publishing models suited to these different data communities. In several cases, the use cases have advanced to the point of being able to transform and adapt real-world data sets into the new models, testing them and revealing their shortcomings. This list represents some of the most advanced use cases in this work. I don't have time to go into the details of them all here, but I want to bring this talk to a close by focusing on the last one listed, ecological inventories. This corresponds to that fourth class of data sets, sampling events, that GBIF supports. GBIF actually introduced the sampling event dataset class in 2015 when TADWIG, or Biodiversity Information Standards, the body responsible for our community standards, introduced changes to the Darwin Core vocabulary that enabled us to support this richer format. So we have something to work with at this point. Then, in February of this year, TADWIG ratified a comprehensive set of changes in Darwin Core Standard related to ecological data. Came last year with the ratification of a Humboldt extension for ecological inventories. This new extension introduces the ability to include explicit documentation about sampling protocols, scope, effort, and completeness, all of which are essential for inferring records of absence. Not only does this enable our network to support and mobilize more complex, hierarchical long-term data sets, the changes also happen to align with current areas of interest and focus across the network, from meta-barcoding data to camera traps to freshwater and marine data. This richer data type will enable us to support more complex modeling and trend analysis of interest to many of our key partners like OBIS, Geobon, and eBird, among others, as well as the companies and policymakers who need to monitor change in biodiversity over time and across many different scales. There's a great deal of work ahead to be done in support of this effort. Searching sampling event data sets on gbif.org now is challenging and not really suited to a different kind of search, one that's aimed at finding data across comparable methods rather than by taxa or place. In the example here, a simple text search for veen returns a dozen sampling event data sets that rely on a common method for sampling seafloor environments, the Van-Veen grab, but with no way of easily exploring or exploiting the records together. So, in addition to the technical features and requirements, our work program for 2025 includes many activities focused on supporting publishers and users who want to contribute to improving monitoring of the state and trends in biodiversity. So do please watch this space. Recognizing that in a short talk like this can only skim across the surface of some of these very complex initiatives, I hope this gives you a sense of some of the initiatives underway at GBIF and how we feel that they aim in one broad way or another at improving the quality and usefulness of biodiversity data that our network can supply. One last note, again, I apologize that neither my colleagues nor I are present in the room for this session, but I'd encourage those of you who have questions or want to follow up to seek us out here in Cali or send me an email. We're involved in several other sessions, which you can find listed on our website, along with a map showing the location of our booth. So with that, thanks again, and look forward to hearing from you.
So we're switching over to the last part. We have about 10 minutes left. We did get a couple of questions in the Q&A from some of you that I'll read out. Well, it's loading up on my end. Okay, so first question is for you, Carrie. Is it possible when we know the distribution of a species to predict potential locations where the species could be with the iNaturalist, the geo model?
Yeah, so the geo model is still a work in progress, and it definitely makes some not great predictions sometimes. So we're trying to understand, especially when that does happen, what factors are contributing to that. It sounds like you might be asking about comparing the known distribution of an organism to the predictions from the geomodel. That's one way that we're trying to assess the accuracy of the geomodel for taxa that do have well-known and generally accepted to be correct range maps. But that's not the case for the vast majority of taxa. So we, at this time, don't really have a good way of sort of crowdsourcing feedback on particular errant bad predictions from the geomodel, but that's something that we might explore in the future. I hope that addressed at least part of it.
Okay, another question for you, actually, Carrie. Can an iNaturalist user consult the species distribution model to view the distribution of a species?
Mm-hmm. So the easiest way to see what the current, the easiest way to like find where a species has been observed on iNaturalist is to look at the existing observations and that map of observations, and that's very easy to do. To look at the geomodel, it's actually a bit buried in the taxon detail page for a particular organism. If you want to send me an email at carrie@iNaturalist.org, I can try and get you more specific instructions for how to find that for each taxon.
Okay. I'll share one question for you, Renan, since I know we got before. Is how come there's so much data on bats within the Shuriken application?
This is based on the studies that are carried out by the teams on the field, and specifically in the framework of wind farms. We use specific recorders to collect ultrasound samples, and we have always a lot of information, a lot of data, a lot of single sound events. That's the reason why, both because of the demand and because of the technology, we have so much ultrasound bat recordings in the database currently.
Great, thank you. Want to check if we have any questions from the audience here? Okay, Terry.
I'm curious to know if it's only people from BIOTOPE using Shuriken right now, or if there's any external users.
Right now, it's only people from BIOTOPE that we are trying to develop, and also maybe to develop simplest tools for additional uses. And if I know where we are in discussion. It has been framed for in-house purposes, for in-house process. because as we are a company, we need to have to be sure about the quality of the data, and to be sure about the time we spend to analyze the data, and then the time we spend to interpret and to illustrate the data, to map data, for example. So this has been designed in that purpose, and opening that, for example, to local partners, it's on the way, but not fully operational yet. But of course, any people having a tablet with the software can use it. It's currently it's private, let's say.
Great. If there are no other questions, I want to thank Carrie and Renald and Kyle offline for putting a great session together. Also want to thank my colleague and friend Cedric, who's in the audience and also did a lot of work to help prepare this session. And here on site, Sophie will help with the logistics. And thank you for people who came on site here in Cali. Wish you a very good COP. Please stay tuned on the events that we have in Casa BIOTOPE. Tomorrow we will have a very nice session from some of our German colleagues showing how they use drone technologies. So using drones in different environments, and we'll have two presentations, one in German from a German use case, Arctic use case, and a use case from Colombia. So we hope to see you again on a webinar tomorrow, and that will be better with all the logistics. Wish everyone a good morning, a good afternoon or evening, and take care. Bye-bye.
Thank you.
Many thanks.